So now we're going to get into the first equation here. So it kind of gives everything down here. Okay, so I have x squared over a squared plus y squared over b squared equals 1. Now notice this, my a is bigger than my b. Okay, so it's saying, hey, this number down here is larger. So I always just use that to realize that once I see that larger number there, I know that's the way that's going to be the longer side. So that's going to be longer on the axis. So that's what I know right away by looking at this. Now if my b was bigger, which they never do that, they always switch the formula up in this book, then I would say, hey, it's going to be longer on the y. This is how I determine which way the major axis is going. Now, it doesn't always have to go on the x and the y because we can get shifts over. But I can say that it's longer horizontally or longer vertically. And they're always going to go through the center. So that's one way to consider these as well. So let's take a look at this picture here. So it is just what I said here. So my A was larger than my B, so that means I'm going to be a horizontal ellipse. So we can call this a horizontal ellipse, and that kind of helps us to distinguish between the two. Now there's another component they kind of introduce here as well. It's not just as simple as knowing this one's bigger so it goes in this direction or that direction. But there's another component called C here. Now if you look at the relationships here, it says b squared equals a squared minus c squared. And c is going to be the distance from zero to the focus. So that's what C is going to be. So that's something to make note of as well. So we're also going to have to find this C. And that's this other component. And it's derived by this equation here. So if I know B squared and I know A squared, then I can find C squared. And that's going to be crucial here to find out where the focus is from the center. There's no nicer way to do that. So let's get into a problem now. So here we go. It says, find the vertices and the foci and graph. So let's take a look at this now. So that means right away, we kind of know quite a bit of information just looking at this form. Now remember, when I have x squared over some number plus y squared over some number equals 1, the equaling 1 here is the component that tells me that it's in the form where I can tell everything about it. If that was any other number but 1, I would have to get it so that it equals 1, so then I can talk about all of its characteristics in its simplest form. So that's how we're going to start with this problem. So now remember what our form is. It's right here. So it's x squared over a squared plus y squared over b squared equals 1. So this is our general form in which we can tell everything, not everything, but a lot of the components about our ellipse. So now that tells me this A then is going to be my distance on the x from the center. And now we're only on the x because notice I have x. This isn't a shift here of the x and the y, so that I am at the origin. So it's another thing to kind of keep in mind. That's going to change for us later. So anyways, so now when I look at this, I'm going to say, hey, this is x squared over 5 squared plus y squared over 2 squared equals 1. Now this is exactly in the same form as the general form there for any horizontal ellipse. And I know it's horizontal because the 5 here under the x is bigger than the 2 under the y. So therefore, that tells me it's going to be longer on the x, which tells me it's going to have the major axis on the x. And I can see that immediately. So now what I'm going to do is I'm just going to graph these points here. So I do know right away that on the x-axis, it's going to be 5 from the center. And it's on both sides. And then right away on the y, I know, whoops, that it's 2 away. And I could put those in right away. And if I wanted to, I could even put the ellipse on now, which I will. So there it is. I cheated a little bit. I used a drawing tool, but it looks pretty nice. So anyways, I know that right away. And I know that this is 5. I know this is -5. I know this is -2 down here, and this is 2 up here. So right away, from this equation, I also know the vertices almost instantly here. So that's going to be here and here. So I'm just going to write those down over here. So the vertices, and again, they're always on the major axis, which is not usually, but it is the longer length. So those points are going to be -5, 0, and 5, 0. Then it also told us to find the foci. Now that's going to be the more difficult part of these. Not that it's impossible or honestly really hard, but we're still going to have to find them. So how to find the foci is, remember we had that formula on the previous page. It's right here. This b squared equals a squared minus c squared. So we're just going to use that idea here. So we're going to say, okay, we got b squared equals a squared minus c squared. Now again, these formulas are handy, but I always think of this here is going to be my largest side, and this here is going to be my smallest side. And I mean side meaning my distance from 0. So just kind of keep that in mind, because there's really no sides here. So I guess I should be a little more clear with that. So my A would be my longer length from the center to the edge. I guess I can talk about it that way. So anyways, so now that we kind of have this formula here, this is all we're going to use to find it, because we know A and B, don't we? So b squared is going to be 4. A squared is going to be 25 minus c squared. So then when I move that 25 over, notice I'm going to get a negative there, which means this has to be the larger one if I'm going to get something positive every time. So I just kind of look at it that way, and I don't have to memorize all these formulas. Just one, and just saying, oh, it's going to be the largest side here. Okay, so anyways, so now when I move that over, I'm going to get 21, is it? Yeah, I'm going to get -21. So I'm just going to write c squared equals 21, because I'm going to multiply both sides by -1 at the same time. Then I square root both sides. So then I get c equals square root of 21. Oh, that's a nasty number, but that's okay. All numbers are acceptable. And remember where c was at from the drawing in the original. So it's here. So this here is my c. So that c is going to be the distance between the center and one of the focus. And that's going to be what that is. And since we're going from 0, I'm going to add square root of 21. So it's just going to be square root of 21 for that one there. So all I'm going to do here is that same thing. So when I take a look at this, that means, where's the square root of 21 at? And so the square root of 21 approximates to 4.582 blah, blah, blah. So that tells us then it's a little bigger than 4. Well, 4.5, I should say. So that's going to put it way out here. And then I got another one over here. Oops, wrong place. So those are going to be quite a ways out there. And also I got to label those. So in the process of this, it wanted me to find the foci too. So that's going to be, and I would simply write negative square root of 21, comma 0. And then I would write for the other one, square root of 21, comma 0. So I should write those out in the radicals, but when I graph them, I definitely have to approximate to write the, to graph them on the number line there. So anyways, so that's going to be those points there. Oops. All right, so there they are. So I'm going to call that F1 and F2. And is there anything else that we're forgetting? So it says find the vertices and the foci and graph. And that's what we did for all three of these. So it looks like we're done. We finished the problem.